Good afternoon, everyone. Thank you for being here. I'm Jeremy Picot-Clemente, Technology Manager at EPIC, and I'm really pleased to moderate this session and this EPIC online technology meeting on photonics for automotive lighting. Few words about EPIC. So EPIC is the European Photonics Industry Consortium. We have now more than 800 members, and we act as we try to promote the photonics European industry. We offer different kind of services to members, technology support, market and technology reports. We offer also some networking opportunities by our event, access to market as well, mentorship support, HR support, and also investment support. Here is the EPIC team. So we are now 12 people working at EPIC, all passionate by photonics. We have 3 different teams, the marketing team, the event management team, and the technology team. I'm personally a part of the technology team and in charge of optics and optical system. We have also Antonio Castello, who is in charge of biomedical and lasers technologies, and Ivan Nikitsky, in charge of integrating and quantum photonics. I would like also to present you a few of our next events. So the physical meetings and also online meetings. So about physical meetings, we will be at W3 Fair in Wetzlar in Germany in a few weeks with a tech watch and also a VIP breakfast. We'll have also a presence at OFC in San Diego, where we'll organize a members run, a members lunch, and also a VIP networking reception. The biggest event we'll have this year is, as always, the annual general meeting, which will be organized at Juan-les-Pins in France, the 16th to 18th of April 2024. And we are expecting to welcome about 300 people, 300 companies there. We organize also a technology meeting on agri-food industry at DigiFood in Oslo, Norway, end of April. So you are warmly welcome to participate if you're interested in these topics. About online meeting, we'll have next week an online technology meeting on Earth observation and monitoring. Then we'll have something on quantum computers. We'll organize also the 20th of March 2024 an EPIC online marketing meeting on social media, special focus on B2B companies. Then we'll have something on photonics technologies to improve pharma processes. And the 9th of April, we'll have an online session on membership benefits, information, and updates. Few words also about European project where EPIC is part of. So we have Photon Hub, an innovative hub offering comprehensive range of supports to industry. We're also part of JPIX. JPIX is a manufacturing pilot line for indium phosphate PICs. We are part of MedFarm as well, a pilot line dedicated to new photonics technologies for medical diagnostics. We are part of Fabulous, which is a European pilot line for manufacturing of freeform micro-optics. And we are also part of Pulsate, which is an European network for empowering SMEs digital competency in laser and additive manufacturing. Few more words about Fabulous. So Fabulous is, I just said, the pilot line for the manufacturing of freeform micro-optics components. And we offer a new service for European companies, which is actually a feasibility study through the Fabulous pilot line. And you can access to 2 months of development effort by our partners with a maximum of contribution of 2,000 euros. And the process is quite simple, and you have a quick evaluation. So if you need more information, you can contact me, contact us, contact EPIC, or you can find also some information on the Fabulous website. And I would like also to remind you that we offer to members the access of this technology report on freeform optical systems by Oliver Fandler, which has been released end of 2023. Here is the value chain of the today's OTM. So as you can see, and as I said at the beginning of the introduction, we cover the whole value chain from the component and modules manufacturer to the system integrators and users, including equipment manufacturers, metrology and testing companies, materials companies, we'll see some presentation related to this during this meeting. Software and design, of course, distribution, contract manufacturer, and of course, research and development. Here is an overview of today's agenda. So 8 presentation. The first one will be Ella Forvia by Daniela Karthaus. Then Dominika Gonet from Noctiluca, Arthur Podorodecki from Q&A Technology, a presentation from Oliver Matisek from Dilo, then Robert De Dion from Luminous. We will have also a presentation from Focusrite Technology with Harald Peer, Tanya Thiel from Technoteam, and we will end this meeting with Henrik Madsen from SPIO Systems. So thank you very much. You are also really welcome to ask your question after each presentation. If you have, you can raise your hand through Zoom. And now I would like to thank you very much for your participation, and I'll leave the floor to Daniela for the first presentation. So Daniela, you can start.
Yes, thank you very much. So let's share the presentation and skip here. So maybe you can give me a short hint that everything's working and you see the presentation?
Yes, you can start. Perfect.
Thanks very much. Yeah, so I'm really happy to have this presentation today. My name is Daniela Karthaus and I work as innovation technology scout and optics engineer at Forvia Hella. And today I'd like to talk a little bit with you about the blockers and enablers for micro and nano optics in automotive lighting applications. So before we start, I have here just a short slide about one topic that is always to be discussed, the correct categorization of optics that we are talking about. So in general, of course, we can categorize optics according to their size as macro optics, micro optics, or nano optics. So we have a millimeter range, micrometer range, or nanometer range. But we can also categorize them according to their physical principle as refractive optics, diffractive optics, and I called it quantum optics. So if anybody in the meeting has a better wording for that, please let me know. But I think it's clear what I mean with that. And in these categories, we have the different types of optics. And often we have a problem that somebody is talking about a really specific type of optics, like, for example, a binary diffractive DOE, binary diffractive optical element, but he's talking about micro optics in general. So it's a little bit difficult then to know what exactly is meant by the characteristics and the like. So it's important to be really specific here. And to let you know, today I will talk about micro optics, meaning refractive and diffractive micro optics, and nano optics, more in the region of here, diffractive optics or meta optics. And I'd like to start with general enablers that we see for micro and nano optics. For example, you see here the image where we have an aspheric lens, a macro optic, and beside we have micro Fresnel lens with the same functionality. And you can clearly see that we have a low volume, a low material consumption, we have a low weight for this component, and with that we have a lot of advantage concerning installation space when we use this type of optics here. In addition, the structures of micro and nano optics is of course really small, and with that nearly invisible. Not the structure size in general, because we always see that something is there, there's some structure on the surface or something like that, but the functionality is invisible. So when we switch on the light, we see, oh wow, this is happening, and this is really an aspect for styling for us, a great advantage here. And in addition, we have, of course, high efficiencies that can be achieved with micro and nano optics. And these are, from my perspective, exclusive characteristics for micro and nano optics compared to macro optics. And in addition, we have a wide range of functionalities. We can use them all for illumination, for imaging, and we see a lot of different potential applications like diffuser optics, as you can see it in the image here, for the flat light that I will highlight a little bit later. We can use them for beam shaping, for projection, or for headlamp systems, for compensation of aberrations, then in connection with macro optics, of course. But there are a lot of different applications that we see here. Why now we don't use them for every application I mentioned here? This is the topic of blockers, and I will come to that later on. First of all, maybe I'd like to give you a short insight about the developments at HELLA concerning micro and nano optics. And I'd like to start with the Fabulous project, so I don't have to explain it anymore because it was already introduced here. And HELLA is one of the use case partners in the Fabulous project, and our target is to develop freeform micro-optics for headlamp applications. And you see here two examples for the different structures that we evaluated until now. And this one, for example, is generating a kind of low beam distribution. So maybe more a tendency towards a low beam distribution. We are still working on that. This was just the first step, but it's really promising. And we clearly see a potential here for refractive micro-optics. Then the topic of flat light. Flat light is a technology where we want to generate really thin modules for signal and tail lighting applications. So they should have a really homogeneous appearance, and they should have a really high efficiency. And with the flat light micro MX that is shown here at the top, we achieved that. And for that, we used an optical stack with different optical layers. So in the region between 3 and 5 layers. And each layer has a different micro-optic structure between, in the region of several micrometers up to 100 micrometers. And with that combination, it is possible to achieve our targets here. And in addition, we have, of course, the flexibility to combine this flat light technology with other technologies like displays. And then we have a digital flat light. But to come back a little bit to micro-optics, another topic for us is holography. And this is my favorite topic because I worked on this during my PhD research. And we see holograms as one example for decorative elements. This is the nature of holography. So this is, of course, one of the topics. And you see here in the image an example where we generated a nice 3D appearance with text and a kind of mirror surface just generated by a hologram, which is really a nice, eye catcher, let's say. But we also look for functional elements, and this is shown by the other image where we want to combine, a nice tiling with a tail lamp function, or as you see it by the schematic image here, we also look for headlamp application. And these topics are still under development on research level by my colleague, Mr. Hiller. And we are really curious about the results here because this is, of course, then really a push for the topic of holography. And one other aspect is meter optics. So as an example, I have here the topic of a meter optic projector, where we want to generate phase holograms with meter structures and use or generate really small projector systems for projection around the car, for road projection, for communication. And here also my colleague Mr. Hiller showed last year some results, and we were able to achieve really a high efficiency, and we have a really good visibility of our projections even at daytime. And of course, this is something, especially with look to autonomous driving, a really interesting topic here. Of course, the list is not complete. We could also talk further about diffractive optics in different applications, hybrid diffractive refractive optics. But I think as an insight for you, this is enough because otherwise I'm running out of time. And therefore, I'd like to come back to the topic of blockers. So why is this list, another reason why this list is maybe short. And the main blocker I see currently for the usage of micro and nano optics is the mismatch between LED characteristics and optics characteristics. So I just had an example with a meter optic where we used a laser diode. But typically, if we have the choice between LED and diode, we choose LED. And therefore, we have these challenges I want to list here is the first one, the polychromatic spectrum versus wavelength selectivity. So even if we use a narrowband LED, we get trouble with dispersion, especially when we talk about diffractive optics or holograms. Then the LED chip sizes and the optic sizes. So we are getting smaller and smaller with the optics. High power LEDs for automotive are typically still in the range of square millimeter or slightly below. And the main challenge with that is related to the next point, that the emission characteristics of the LED do not match with the characteristics of the design light source. And typically we there have point or parallel light sources, and an LED is a Lambertian radiator, or if we are getting closer and closer to the LED with our micro and nano optics, we have a surface emitter. And then we get really into trouble when we design this for such ideal light sources here. And the last point is that we often have to use multiple LEDs because we have to fulfill legal requirements, and the intensity of one LED is not enough. And then, we have the trouble that the design of the optics is for single sources, but we illuminate them with multiple LEDs. And one effect is, for example, as you can see it here, the appearance of ghost images, as an example here with holograms. Also, this list is not complete, but I think it shows the direction where we're going. And I'd like to summarize this in a few keywords or a few key sentences. So I think our developments at HELLA show that there is a great potential for micro and nano optics for automotive applications. But the main blocker is currently the conflict between the LED and optics characteristics. And I see two ways for further developments. The first one is the improvement of design approaches so that we can optimize the micro and nano optics better for LED illumination. And the other way is the optimization of the light sources for the design approaches. So we have the trend that LEDs are getting smaller and smaller. And with that, of course, we have again more ideal emission characteristics, and we can then again use the current LED design approaches with the LEDs. And I'm not sure which way is the fastest one, but I see these two ways as the great chances that we have to bring the micro and nano optics to a widespread use. And with this, I'd like to end my presentation, and I stop sharing the screen to see you again and to discuss with you about these statements here.
Thank you, Daniela. Thank you very much for this nice presentation. Any question from the audience? So you can raise your hand through Zoom. Maybe I will start. No, we have, okay, Eugene Mayer from ANSYS, please.
There is the unmute button. Can you hear me?
Yes.
Hi, Daniela.
Hi.
Just one small question. You mentioned whenever you have the choice between lasers and LEDs, you go for LEDs. Is there a specific reason for that maybe outside of the automotive world we don't understand?
From my knowledge, the lumen output per euro is for laser diodes still not that good than for LEDs.
Okay, that's commercial reason.
Currently, I think this is one of the main reasons, but of course it depends on the application, because if we have headlamp applications or something where we where we could get in trouble with laser safety, then of course the effort for laser safety is much higher than using an LED currently.
Yeah, thank you. I remember there was from BMW this approach with converted blue lasers for headlamps several years ago. I remember similar discussions back then. Yeah, thanks.
Yeah, you're welcome.
Thank you, Eugene. Any other question? Okay, yes. So Michael from DVN, Michael Ham from DVN, please. Michael, you are muted.
Now I'm on. I think I'm now.
Good.
Yes, you hear me?
Yeah.
Yes.
Daniela, it looks very great that you can make out of a 10 to 10 millimeter a low beam application. But I think it will not be perhaps sufficient if we look to press through this 10 by 10 millimeter about 1,000 lumens. So what is your estimation? How many of these small pieces do you need?
Well, we have not finalized the development yet, but I think between 5 and maybe 8, or it's depending on what we want to do. So for one low beam, I think maybe 3 or 5.
Okay, thank you.
Thank you,
You're
Michael.
welcome.
Yes, we have a question from Robert Little from the Fraunhofer IOF. Robert.
Hi, this is Robert. Short question about the taillight application, or can you give some insights in this, and in what are you doing to make this efficient from an, for instance, LED driven backlight, or comparison, because there were some years ago, or some applications use OLED as an aerial emitter. What is the trends, and or what are the trends, and what could be done from the optics point of view to make it more efficient?
So for the floodlight, we currently use LEDs. It's an edge light or edge lit light guide, and we use then the optical stacks in front of. And the different stacks, that this is really the point, that we optimize them for each other, and then we get the high efficiency out of it. So currently we are compared, I don't have an exact value now for you, but currently we are about 80% more than typical taillight functions, or taillight technologies, sorry, not taillight functions. And we can realize also stop light with the flat light.
Okay, thanks.
You're welcome.
Thank you, Robert. One last question, maybe? Okay, so thank you very much again, Daniela. Thank you very much for opening this meeting. Thanks. So let's move now with our next speaker. So Dominika Gonet, key account manager from the Tiluca. So Dominika, you can share your screen and start your presentation. The floor is yours.
Yeah, of course. Can you see my screen?
Yes, that's good.
Okay. One moment. Okay, first, let me thank you for the chance to give you this presentation. Oh, thank you. Oh, okay. About Noctiluca as your dedicated R&D team and materials provider. My name is Dominika Gonet. I'm key account manager at Noctiluca. And our motto is we transform knowledge into technology development. Noctiluca is a deep tech company located in the heart of Europe. We're based in Toruń, Poland, and here we have our R&D team, our business development team, and head office. Our management and employees are specialists in their field. We are a trustworthy company because we have a set partner as LG, Inuru, TCL, Filken, and many others, which I can say about that. We cooperate with institutes and universities like Fraunhofer, EIP, ITRI, or KHU. At KHU, we work with Professor Kwon and his technical advisor on our R&D team in KHU. By contract, we can use their laboratory and their research our compounds. We are part of Syntex Group, which have partnership with UPL, Sumitomo, Johnson & Johnson. And our financial stability and unlimited growth potential are the best demonstrated by fact that we are listed on Polish stock exchange and New Connect, and we must do financial report every quarter. We have global reach and team members in United States and partners in Taiwan, China, Korea. That is short introduction about Noctiluca. And now I want to say something about what we do. We operate, as you see, in 4 different areas. We start with our own research. We focus only on. We was focus on development, high efficiency third, fourth, and 5th generation emitters for both OLED manufacturing method, PVD, physical vapor deposition, and IJP inkjet printing. And then when we offer these emitters to our customer, they ask us about different compounds for their stack. And that is why we have custom synthesis of known materials. We can deliver for you a variety of organic materials, not only OLED materials. And after we provide our compounds to our customer, and they ask us, can we help them with their problem with stack? And that is why we have chemical contract research organization services. We can be dedicated R&D team for another organization. And all these areas lead us to sublimation services, because as Noctiluca, we proud ourselves to being a producer compounds known for their unparalleled quality and purity. And there is why we offer sublimation services even in semi-industrial scale. Now I say you something about that what can be the most interesting for you, and that is chemical contract research organization services. Although Noctiluca established in 2019, our team has 15 years of experience on the most challenging chemical project. And this practice comprehensive their knowledge and experience in the complicated world of organic chemistry, and we take care on any challenge in organic chemistry. Our team can support you in different part of organic chemistry. We have experience working with substance sensitive to air and moisture, with dangerous compounds, with design and optimization, synthesis, optimization, reaction conditions, and optimization purification methods on and every part of organic field. To have better understanding what we do and what we offer, I show you the example of our business model as a chemical CRO. We have full flexibility in these models. Each time we tailor the model to meet the client needs. We do what the client exactly want, not what we have in our table. When we start to work with a new client, we determine in which part of the project we can help, we should help. And you see the five business areas, 5 areas when we can be your R&D team. The first is business challenge. Usually that is and the client comes to us with their challenge and ask us about how to do it. And the next one is source of idea for the solution. And the next one is a source of synthetics process. And the next one is executor of synthetics process. And the last one is always commercialization. To have better understanding, I shortly show you some our use cases. And the first is use case about working with MIT spin-off. And they looks for long-term partner with experienced team with top infrastructure, and now we have a day-to-day cooperation with them. And the client have access to our laboratory and equipment. We dedicated Noctiluca members to develop new monomers and support in solving ongoing customer issue. And that is our work with that company day to day. We see each other and we work together. And the next one was Noctiluca was source of new idea. Our client wants to have next generation transparent, flexible organic photovoltaic cells with efficiency above 10%. What we do, we develop new ruthenium-based dyes and testing it with our customer. That was interesting, and we design and execute it from sketch to the product which are in our partner portfolio. The next one is something different because it's example about dermocosmetics. It's beauty industry. It's not only OLED in our portfolio. Our client wants to have new product with antioxidant. And they don't know what they need. They need antioxidant and good product. With client, we choose the most potential natural plant antioxidant with antifungal and antibacterial properties. It was xanthohumol. But that was the problem with durability, that xanthohumol, XN in a short name. But we solved that and develop a synthesis method encapsulated in cyclodextrin. And the results was so great, and we have publication with our customers and patent, and now they have a line with dermocosmetics product. You can see that it's Proix and xanthohumol product. And the last one is the most important because here is about OLED devices. In this case, we was executor of synthesis process. The customer know which compound they want to test in their OLED devices to improve their efficiency, but they didn't have any chemistry knowledge and any laboratory. And first, what we do, we produce these 5 materials for our customer to test. And after the test, they choose one and ask us, can we do optimize synthesis and purification process, and we do that. And now we are producer that compound for the client. And I try to show you how we work. That is only 4 short examples our work as chemical CRO. As you see, we work not only in OLED field. We are specialists in organic chemistry. We have fully equipped laboratory, and we can offer you all our services. And I think it's all. Here you have the QR code. You can scan it and have contact to me. And it's all, and I will be happy to answer your question if you have any.
Thank you, Dominika. Thank you very much for your presentation. Any question for Dominika? Maybe one from my side. If we talk especially about the automotive industry, are you today able to answer the requirement of this specific field of application?
No, in car industry we don't have. We now do something in lighting, and that is that step. We start do some research about lighting, and we start working about with that, and we want to try a little bit more with inkjet printing, which can be the proper way to have OLED in this case.
Okay, thank you, Dominika. Any question? Okay, so thank you again, Dominika. Thanks a lot.
Thank you.
One with our next speaker. So Arthur Podolodecki, CEO of Q&A Technology. So Arthur, you can start your presentation and share your screen. Perfect.
Give me a second. Yeah, okay, I'm ready. So I hope you see my presentation.
Yes.
Thank you, Jeremy, for this nice invitation for this meeting. So I'm CEO and founder of Q&A Technology, the company working on development of nanomaterials, inorganic nanomaterials. So we are materials producers. We accept the materials development. We focus also on technology development. So this is what we do in our company, just keeping the scale as well as quality of our materials. We also do surface modifications, which is quite important from application point of view, as we can adjust our materials to the type of solvent, type of matrix we are going to disperse our materials. And we also offering ink formulation, just to enable our materials to be printed. We are focusing on nanomaterials are quantum dots. So we are developing the quantum dots. The quantum dots are small crystals of semiconductor. They have a size around 10 nanometers. They have a very high quality core, which is responsible for the quality of the material, and the organic surface, which is responsible for dispersion of these materials in different kinds of solvents. So quantum dots, you can think about these materials as some kind of alternative for organic dyes or for phosphorus. They have a very high quality, the color quality. You can tune the peak position very precisely with the nanometer precision. The broadening of the emission could be even as small as 10 nanometers, which is really comparable to even lanthanides or these kinds of materials. They are usually they have a very efficient and broad absorption band, so which has a benefits because you can excite several cores using just one LED, for example. And usually the absorption is also very high. Coefficient of absorption is very high. And in some cases, the quantum yield, so the emission, the conversion of power is close to 100%. And I think the also very interesting property of these materials is that they are quite stable because they are semiconducting crystals. So in our company, we decided to focus on blue light emitting quantum dots mainly. So we try to cover the spectral range between 400 nanometers up to 470. So this is our goal for right now. And our materials are heavy metal free, so no cadmium, no lead. And yeah, this is our flagship material. Our main market are displays. For now, we are focusing mainly on electroluminescent displays. So this is the technology which I believe will come to the market in the next years, but also our materials can be used for micro displays, but the very special kind where you use the UV backlight instead of a blue backlight. And for the moment, we are also considering the lighting market, as we believe that there's also a lot of potential for our materials for this market. So our company is located in Wrocław, so not far from Germany. In the technological park, we have 6 labs. We are 25 people right now. Most of us are R&D team. Me, myself, and my colleague, who is also co-founder, we are physicists by the background. So trying to, to understand the devices as well when we are designing our materials. And this is a few more technical data about our materials. So for the moment, we have 2 types of blue quantum dots. The one is deep blue, and this quantum dots have a quite narrow emission. This could be even as small as 10 nanometers, and the quantum width around 80%. But for the display industry and in general for color management, the pure blue color is and so the 455 nanometers is laser wavelength. So we are focusing on this quantum dots right now. So as you can see, the browning can be also very small, and the quantum at the moment is around 75–80%, but the material is still under development. We are trying to develop our materials toward 2 kinds of application. One we call photoluminescent. So you get light from quantum dots after the excitation then by the different light, usually the UV light or just the wavelength, which is shorter than the emission wavelength. But the other type of application where we are trying to customize our materials are electroluminescence devices, when you use just a carrier injection to get the light from quantum dots. In parallel to development of our quantum dots, we also work on inks. And for the pure blue quantum dots, our main product right now is a UV curable ink. So we can get different kind of viscosities, different surface tension, depending on the method you are using for deposition of this ink. We can also offer a very high loading. So a lot of quantum dots can be put into the monomer or to the ink in general. And yeah, so this is what we are really working a lot right now. We also start to work on photoresist. This will be for us the next product. We would like to offer photoresist, which will be full of blue light emitting quantum dots. And here you can see some examples of our inks after the UV curing process. So as I mentioned, we are developing our materials toward 2 kinds of application. The main one is the electroluminescence, so like a LED, but the difference is that the LED is done in a wet chemical approach, and in next step, it could be also printed. So here you can see an example of devices using our quantum dots, and we work with the several partners worldwide who are trying to build optimized devices using our materials. And on the right side, you can see the micro display approach, where you use the UV light as excitation. And here you can see a few examples of UV curable inks deposited on glass after the UV excitation. And of course, just making some step towards the automotive lighting. If you put all of them together, you can have a white light, and you can control the temperature of the light, playing with the wavelengths of the red, green, and blue quantum dots intensity. So you have a lot of parameters you can use to get exactly what you want. Except the fact that we are developing blue quantum dots, we have also quite extent know-how regarding the ink formulation using other colors of quantum dots. Here you can see some examples of inks we were developing for people interested in printing quantum dots on glass, with the high resolution on the plastic foil, on paper. We can also mix the different colors of quantum dots into the one host to get a very specific color. That's it from my side. We are at the stage looking for partners, especially in automotive lighting, as we really would like to optimize our materials for a very specific application. Thank you.
Thank you very much, Arthur. Thank you very much for this interesting presentation. Any question for Arthur, please? Yes, we may hear talk from AMS Osram, please. You are muted. Yeah, good.
Hi, Arthur. Thanks for the interesting presentation. Maybe a more application-specific general question. If you go back to the application of using quantum dots in converted applications for displays. Nowadays, usually we use blue pumped backlight source, red and green converters to get your primary colors. What do you see as the main advantage of stepping away from this, I have to say, more or less ideal blue backlight source towards UV sources and then using your blue quantum dots instead?
Yeah, sure. So at least there are two very important advantages. The first one is that when you are using the blue backlight, you get in the same pixel the red color, for example, and there is very often the blue light leakage at the same space. So the color quality is not a very high. So it's a very big challenge for this kinds of approach. When you switch to the UV backlight, you don't have this problem. You just put a one filter at the top, which will cut off any UV light, and you don't see UV light. So you have a very pure red, green, and the blue. The other advantage is that if you look on the absorption spectrum of quantum dots, the more to UV you go, the absorption is higher. And if you switch from 450 to 365, it could be a difference by a factor of 10. So it means that the conversion efficiency for red and green quantum dots could be 10 times better than when you will be using the blue light, which means, for example, that the thickness of the layer of quantum dots could be much smaller, and at the end, the price of the device could be much cheaper. So these two are most, I would say, close to me, but I also know that when you reduce, and the problem could be when you start to reduce the size of the LED. When you reduce the size of the LED, the efficiency of LED is dropped. And for the UV diode, it's going much slower than for the blue. At least this is what my colleagues working in this area told me. So there are also some electric type advantages, but from the optical point of view, I think these two I mentioned, better absorption and better color quality are the most important.
Okay, clear. Thank you.
Thank you, Ben, for the question. Any other question? Yes, Harald here from Focuslight. Harald.
Hello. Yeah, thank you for the nice presentation, Arthur. Did you try to mix these in some way with phosphor to make white light?
Not yet. That's why I was very happy to join this audience, because so far we were focusing only on display. We were only mixing the colors like red quantum dots with the green quantum dots to get orange, but we didn't mix this with the other materials like a KSF or something like this. But yeah, I think it's possible because, as I mentioned, we can control the ligands, the surface of our material, so we can select them in the way to make them dispersible in a very specific monomer solvent, so adjust a little bit them to the phosphors, for example.
Thank you.
Thank you, Harald. Yes, Wim, you have another question.
Yeah, if we start talking about like general lighting or automotive lighting applications, I'm immediately thinking of a big problem we also had or have with quantum dots, and that's robustness. So as you might know, automotive applications are incredibly demanding, very high temperatures, and then ideally an optics designer wants a very small, high intensity light source. How do your quantum dots handle that?
Yeah, so this is hard to answer because it depends on many factors. So I think there's no so very general answer. It depends on the thickness of the film, on the host, on the concentration. We start this kind of test very recently, and what I can say is that when you have a relatively thin layer of quantum dots in the UV ink form, there is no degradation up to 150 Celsius degree. We start to observe a degradation above 200 Celsius degree, but this is something which you can still work on. You can make a thicker shell and change the ligand. So this is some space for improvement, but sure, you cannot go to 500 degrees or something like this, right? So I think it will be very challenging, but 200 and below, it should be doable.
Have you done any comparisons to standard YAG phosphor or something?
No. This was not our mainstream so far. As I mentioned, we were so far focusing on display. So.
Okay. Yeah. Thank you.
Thank you, Wim. And yeah, thank you again, Arthur, for this interesting
you.
presentation, which was a lot of questions. That's good. So let's move on now with our next speaker, Oliver Matisek, Product Manager at Dilo. So Oliver, you are welcome to start your presentation.
All right, perfect for the introduction. Can you just confirm that you can see my screen?
Yes.
Can you see it in the presentation mode? Is it correct?
Yeah, you can start.
Perfect. All right. So let me give you a quick introduction into adhesives and materials for automotive lighting. And for those of you who have not heard of Dilo before, I just wanted to give a quick introduction here. So Dilo is a company from Germany. Here you can see a nice picture from above. So we are a family-owned company and have a revenue of roughly 200 million with 1,000 employees. And why I want to show you this is because we are active in multiple markets. We are known for adhesives for different applications, for example, in smartphones, in consumer devices, but also in automotive. And what you can see here on this picture is different parts that we are already having quite a lot of experience in with our adhesives, like in cameras, in displays, in sensors, or in electric motors. And a huge new trend that we can see is in automotive lighting. More and more companies are working on slimmer designs, on new trends, new LEDs being used in here. And this is where we are also active in. And this is what I want to show you on the following slides. And as a quick introduction, oh, that was the wrong direction. As a quick introduction, maybe many of you have already seen this article. It's not the newest one, but here we can see, for example, Reinhard Völker from Swiss Micro Optics, which has recently been acquired by Focuslight, talking about microlens arrays. They have the advantage of a precise light with very tiny lit surfaces, still having issues with lower optical efficiency and a higher price. But it was said that this is becoming a revolution in the lighting technology. And we can confirm that there's a lot of activities on the market here, and this is where we are active. So this technology is on the rise from our side, and this is why we are working on it. And just as a quick reminder, this technology works like, for example, in projection systems, when you have a single lens and a single optical component being projected, you can reduce the distance between light source and the optics by using micro lenses, by using a lot of lenses next to each other, with the benefit of being even smaller. And for this, you need devices like the microlens array, where we have 4 different layers. So we can see the optical material being highlighted in magenta here on top and on the bottom, with the glass wafer and the chromium mask in between. And with this double-sided imprinted lens structure, we can accurately align all those lenses to those optical components in the mask. And this is exactly where we are very, very active on developing materials for these microlens arrays. And before jumping into our developments, just as a quick reminder how these microlenses are manufactured. So first of all, we have the liquid polymer or the liquid material being dispensed on a glass wafer. In this case, we are just showing the material in magenta just for marketing purposes. So after the dispensing, we have the imprinting, where we have a transparent stamp imprinting the structure of the lenses into the liquid material. And after that imprinting step, we have the curing of the material through the stamp. So we use the transparent stamp to cure it and to cure through the stamp. And after demolding the stamp from the material, we end up with a finished wafer. And after the dicing, we can just dice out bigger areas. So we end up with microlens arrays. And you can imagine that for this process, it's not only important to develop a material that has a good optical performance, but it also needs to perform in the manufacturing process. So this process is very specific, And for this stamp, we are using the same stamp over and over again to be efficient in the process. And this is something we are looking into together with partners. So on the next slide, I just want to show you a little bit our activities in terms of repeatability. So what you can see here is that we are investigating the height of the lenses and also the diameter. Here you can see the values for the master. So for example, in this example application, we can see a master having a height of 90 micrometers and the diameter of 480 nanometers. And in those graphs, we can see the results of the lenses that are imprinted between different machines. So M1 is machine 1. So we tested 5 different machines for both values and also multiple imprints at every single machine. And the result was that the variation within a machine is lower than 1% for both values. And the variation from machine to machine is lower than 2%. And these are quite good values for manufacturing these kind of optical components on a mass manufacturing scale, resulting in these components. So here we can see a microlens array, the final product. And for us, it was very important to highlight how we can improve the machine-to-machine reproducibility, not only focusing on the optical components and the optical properties here. This was in collaboration with SÜSS Microtech from Munich, where we investigated it together. So we are focusing on improving the material, and they've been focusing on improving the process and all the machine parameters. But besides working only on the process, we of course focus a lot on the material requirements itself. So for the automotive lighting applications with the microlens arrays, I think the most important property is the high transmission in the range of the visible light. So we need to be as high as possible, obviously, to transmit all the light and shape it in the form that is needed. The second important requirement is the optical stability. So this transmission has to remain high even after UV radiation, even after humidity and also temperature storage. So this is where we do a lot of long-term tests to measure the transmission of our optical materials to be as close as possible to the end application in the automotive headlamps. And last but not least, we also checked the mechanical stability, which is very important because with all these long-term vibrations, for example, and the temperature overlay, it comes to stresses in between of those different layers. And this is where we do a lot of mechanical evaluation of those materials being cured in those specific areas and thicknesses. And all in all, in combination with the process, is what we test in order to develop our materials. Let me also jump a little bit into some values here, and I would like to highlight the optical stability. So in terms of optical stability, what you can see here is 4 different products from Delo. So we can see here in the 4 colors, 4 different optical materials that are used in automotive applications in terms of imprinting. And the first group of values shows the transmission at 420 nanometers initially. That means no storage conditions were applied, and the transmission was 100% for all of these. So the initial transmission is very high, but we know from our customers and also from our experience that in these applications, especially the temperature is very important. So what we did was, even though the reflow process is not always necessary in the manufacturing, it shows how the material reacts after a high temperature overlay. So when going 3 times through the reflow process with all of these materials in a layer thickness of 100 microns, we can see that the transmission drops. It goes down, but it remains higher than 95%. So 95% is a little bit of a threshold that we need to be higher. And all of these materials are still higher, but we can see a clear favorite here with the OM6115 being still higher than 99%. And I think the test that is even more relevant for automotive headlamp applications is 125 degrees Celsius. Because in those microlens arrays, we can have quite high temperatures over time, and 125 degrees Celsius is a temperature that we test a lot in. And the newest material still has a transmission of higher than 99%. which is a very good product on the market already. So our current products already show a pretty good yellowing behavior after these aging steps. But what we are currently looking into is still improving these. Even though this is already good, what we try to see is how to improve the transmission after high temperature storage and UV irradiation at the same time. So these are the trends that we can see here. We are working on new products, testing them together with partners, and yeah, you can be, yeah, I can show them to you maybe in the next meetings, but this is a clear trend that we can see here, with these products being our starting point. And in the headlamps where those microlens arrays are used, we see a lot of different bonding tasks as well. So here you can see such a module using a microlens array optic at the top. And this microlens array is often bonded into a housing. So for this housing bonding, you can see the next adhesive being used here in magenta, where we have a different candidate with the OB4189. And also other adhesives being used in these headlamps, for example, for the bonding of the collimating lens or the LED to a heatsink, for example. And for these, we have different products where another team is focusing on. I could see some of my colleagues already also in this online meeting here. But I just want to show you with this that we are working on all the bonding tasks that are relevant in these MLA headlamp applications. And if you have any questions here, feel free to reach out to us. We are very active in testing with our partners together, and we would really like to improve the materials together with you. So feel free to reach out, and I'm looking forward to your questions right now in the chat, or yeah, maybe here in person.
Thank you very much, Oliver. Thanks a lot for your presentation. Any question for Oliver? Yes, Vitor Loya from ANSYS. Vitor, please.
Hi, can you guys hear me?
Yes.
Yeah, just a quick question. Are you guys working to Oliver? Are you guys working on maskless MLAs? And if so, what would be the improvement on using such a system?
Okay, is it two questions now, or do you mean improvement of maskless systems?
Yeah, the question is for the maskless, like if you were to design a maskless MLA,
Okay.
how much improvement would you see?
So we are,
if you know.
So we are not particularly focusing on maskless MLAs, but I have to admit that considering all the ecosystem here, we are only focusing on the material for the imprint. So what our customers in the end do with this material, we often don't even know. So from our perspective, it's just important to make sure that the material meets the requirements in terms of optical performance and also in terms of the imprint. So we are not involved in all the optical design, whether it's about choosing a mask or designing a mask. So this is a question that you would need to ask those integrators and tier 1 and tier 2 suppliers, because they have those long-term trends. So we are really focusing on the material properties and on the imprint process, and the mask in between is something that our partners deal with.
Thank you.
Of course.
Thank you, Vitor. Yes, Robert from iOS.
Yes, I have two questions indeed. The one is about the material again. Do you also tailor the refractive index or the dispersion to certain class kinds or class grades? Or do you also investigate high index materials to get into certain applications where it's needed? And the other question was totally different about your what you have shown with the number of replications. I was not sure why you changed the machine in between.
Okay, so let me start with the first question. The first question was regarding the refractive index, and we absolutely investigate materials with a high refractive index, but it's not highly relevant in these automotive applications. So we don't see the high refractive index being a requirement here. Here it's mostly about being efficient and also stable after these high temperatures and irradiations. And this is where we focus on, because we can see that the higher we go in refractive index, the harder it gets to be stable in these ranges. And we can see a clear trend from our customers that the reliability after high temperature and irradiation is much more important than the refractive index. So for automotive, we don't see the trend of going higher and higher with the refractive index, so we focus on the temperature. But we see that for other applications, like for example, for AR glasses, where you're doing the nano imprint for those grating couplers, for example, here you definitely need the higher refractive index, and this is also where we are doing developments, but then we are talking about completely different products from our side. So yes, we are working on higher refractive index, but not for automotive. So that answers hopefully the first question. And regarding the second one, in terms of comparing the reproducibility between the machines, we are talking about a mass manufacturing here. And we are talking to companies that have multiple machines doing imprints. And in the end, when you want, as a company, want to deliver a product to an end customer, you need to make sure that the product in the end, meet the requirements as close as possible. So we need to make sure that the reproducibility is not only given in one certain machine in one very specific setup, but that it also works in between of different machines, so that you cannot determine via the end product on which machine this was manufactured. So this is just a long-term topic for mass manufacturing, not only manufacturing on one machine, but having multiple machines running next to each other and still delivering high quality in the end.
Yeah, my question is because in the end, it's a question of the interaction between your polymer and the stamp. So
Yes.
and the degradation over multiple imprints of the stamp, and not sure if it has something to do with a machine. How it's only about how many imprints the stamp can survive, and whether there is some diffusion or something else which may cause the shape deviation of a lens.
Absolutely.
And therefore it's about the interaction, and the question is about, do you have materials which are better than others, and are they similar or hopefully they are the same advantages as you shown for the transmission, that you can say, okay, you have a real good material for imprinting which has also no yellowing. Yeah, this is the one. Or are they different? Yeah. And also, I maybe just as a comment for the question before, I think maybe not for the automotive lighting, these high index materials are interesting, but there are a lot of more automotive applications where sensory, not all, where high index materials, or having at least two different dispersions to generate achromatic systems, yeah, would be interesting.
Yeah, so maybe we can have a chat afterwards, or maybe a quick exchange on that. So in the end, also in other applications, in other automotive applications besides the lighting, we do see requests and activities going on with higher refractive index for sure. I was just focusing on the automotive lighting here, so about headlamps in particular. And regarding the comparison between different machines, you're absolutely right. So the change occurs because of the interaction between the material and the stamp, but still we wanted to provide this data to customers to see how the process is transferable to like different machines and the setup with like higher yield and higher amount of parts being produced at the same time. So this was clearly driven by requests in terms of high volume manufacturing. And with this data, we could show that even the comparison between the machines does not show a big influence here, exactly what you just mentioned.
Okay, thanks a lot.
Of course.
Thank you, Robert, for the question. Yeah, let's discuss this afterward, maybe. Oliver, thank you very much again for your presentation, and really interesting presentation. So now let's move on with our next speaker, next presentation. So Robert de Jong from Luminous, VP of Sales and Business Development, EMEA. So Robert, you can start your presentation and share your screen.
Thank you, Jeremy. Is it visible?
Yes, you can start.
Okay. Get rid of this. Okay. So yeah, thank you very much for joining the online presentation on automotive lighting. Luminous, I will tell you a little bit more about Luminous LED solutions for automotive projection later on, and I will introduce Luminous as a company to you. I'm currently in a hotel near Munich Airport. I will join tomorrow the DVN workshop on automotive lighting. I already saw somebody from the DVN team joining this presentation. So hopefully I'll see Michael Harm tomorrow at the DVN workshop. Okay, Luminous. Luminous creates market-enabling products across different segments using photonic innovation. We have best-in-class performance in brightness, and we have several wavelengths that we can offer, and let's say different market segments. So if you look to the core competences, we have a very broad portfolio across different wavelengths, going from UVC up to visible and near IR and IR. Also, one of the highest current densities in the industry, up to 6.5 amp per square mil, which then automatically relates to being one of the brightest light sources in the world, combining this high current density with big chip sizes. We create really bright sources. We have, for instance, for a studio light, a COB with an LES of 53 millimeters, which can almost create 90,000 lumens out of one LED source. Also, it's possible to develop...
Sorry, Robert, I'm sorry, you're still on the first slide right now. I don't know if it's normal.
Okay. No, it says the screen sharing is paused. Why is that?
Maybe try to reshare. Yeah.
Share again. Better?
Yes, you are on the good screen.
Okay. Okay, so as I stated, the wavelengths, the highest current density, brightest light sources. So we also have the option to develop a custom spectrum for different applications. So a wavelength that is currently not available, we are able to develop. So UVB solutions, but also amber or also phosphor converted solutions, combination with certain wavelengths. And that altogether with having, let's say, high current density products, we also need to have very stable packages that can offer excellent reliability at these high currents. Okay, so can you see the second slide now?
Yes, that's good.
Perfect. Yes. So Luminous has a long background and 20 years of experience in micro display applications and solutions. So it all started for Luminous basically in the LEDs for projectors, front projection, later on Pico projectors, but also other special lighting areas where a DLP DMD from Texas Instruments is being used. So for 3D printing, lithography, curing, but also now we are expanding, and that's the topic of today. We're making this projection technology available for automotive applications. Dynamic ground projection, but also interior displays, and that we're doing with RGB solutions or white solutions. So targeted applications. You can see here several interior and exterior solutions, but also heads-up displays, and even high-resolution headlight, sorry. Although this probably will only be for a kind of symbol projection, because the majority of the headlights is moving from a high-power LED source towards the micro LEDs. Okay. What we will relate to later on in the presentation is the dynamic ground projection, which indeed is something where you can show a logo when somebody enters the car, or there are possible signs that you communicate with other vehicles. For instance, if somebody is opening the door, that there will be a sign that the door is going to be opened as a warning for a bicycle or a pedestrian. If the car goes backwards, that there are stripes projected on the ground to see that the car is going backwards. Interior projection. So this is exterior. Interior is more on kind of mood creation, where on the ceiling or in the door panels there will be kind of projection possible. Another one that is basically more on the window itself. It could be used for advertisement. It's clearly that this is pending regulation in each country. It's not allowed that you are, let's say, doing this in any country. It's can be distracting, of course, for other people. Heads-up displays, which can be indeed something for the driver. Instead of looking downwards to a panel, this can be in front of the driver in the screen. So what are the benefits of the luminous LEDs in the DLP applications, so digital light projection applications? So one of the key ones is that we have designed the LEDs to match the étendue of the DLP panel. So the size of our LEDs are matching the size of the DLP panel from Texas Instruments. And with that, there is an optimum optical efficiency and maximum performance that you can achieve. So another benefit is the low thermal resistant package, which gives you a higher reliability. Already stated, qualified up to 5 amps per square mil for blue and green, and up to 4 amp per square mil for red. Red is always a bit more sensitive to higher current and higher temperatures. And of course, dedicated die and package technologies. So what you can also see is that these die sizes have different sizes. So it could go from 1 square mil up to 2 or even 4 or 5 square mil packages. So what are we looking for, and what can you do for luminous? So as always, we're interested in finding more automotive customers, be it tier 1 and OEMs. And in these, let's say, potential new customers, there is always a discussion on requirements. So the lumen package, what is the required lumen output for certain projectors? The size requirement of automotive is always the smaller the better, but that in combination with a high current density light source is not always easy in terms of thermals and in terms of fitting that in a very small size that is offered. And then, there is the question whether it's a white projector or a combination of red, green, and blue. Of course, the red, green, and blue has a higher resolution, but of course it requires more space. So size-wise, the white could be better, but you deliver on the resolution in that sense. And for that, in terms of luminous as an LED solution provider, so we always need an optical partner to build solutions around the DLP DMD device and the luminous LEDs. Okay. Thank you very much. That is the presentation.
Thank you, Robert. Thank you very much for this presentation. Any question for Robert? You can raise your hand. I was wondering, Robert, if you today you are able to answer the automotive requirements in terms of quantities and also quality. Is it something that you are able to answer today?
Yes. So obviously we have certified ourselves as a company for the automotive requirements, and have received the automotive certification. Then it's pending on finding an automotive customer that wants to start a project with us, that we can qualify these specific products for automotive. But yeah, the whole organization up to our wafer manufacturer, which is our parent company, Sanan Optoelectronics, is all automotive certified. To answer your question, are we able to follow the volumes? Currently, we are we're in general lighting and special lighting applications, and producing a lot of volumes for these specific applications. And yeah, we are ready to scale on automotive projection applications and in volume.
Okay, thank you, Robert. Yes, a question from Michael Ham from DVM. Please, Michael. Michael, you are muted if you are talking.
Lautschalten, yes. Thank you. And Robert, we will see tomorrow, because I'm the same hotel sitting in another room which has the same shape like yours. One question is, and I think this is driving the whole community crazy, all these super cute things that you also promote are not allowed in Europe. What do you do to make it, to convince our, let's say, regulatory, more reluctant people?
That's a good question. Well, I don't think Luminous is able to convince a lot of these governments. I think the automotive industry and the governments of some of these automotive manufacturers is quite conservative. Germany, France, to name a few. US is even more conservative. So that's kind of a pity, because it really stops innovations to happen. If I relate to China, which is also an area where Luminous, with Luminous China is active, then we see there is a much faster adoption. And these guys are able to implement automotive projection in cars much faster. At the moment, we are stuck with, say, more or less non-operational modes. So automotive projection currently is used when somebody enters his car and then opens the car, then there is a welcome message being used. So for exterior, it's quite difficult. For interior, I think there we are not limited by regulations that much. If the let's say interior projection is used as a kind of mood thing, and again, that can happen once you're getting into the car or once you get out of the car. So it definitely should not interfere with the safety issues when the person is driving. But you have a true point. The regulations for automotive are hampering a lot of the innovations.
Yeah, that means convince them, make samples, try to show it's not dangerous. That is, I think that is the job for us all, to prove that this is not only beautiful, but it also does not harm, and it's nice.
And I think in some cases it's even improving safety. So if for instance, the example that I mentioned, where if a car drives backwards, the red stripes are being projected on the ground, that provides safety. And especially a lot of people on a bicycle or even pedestrians, they are having these nice AirPods in or headset, and they don't hear the car anymore. And in an electric car, you don't hear even that well either. So I think having signs that the car is moving into a certain direction will improve safety. And the same for projection from headlights. So I don't think DLP automotive projection will happen for headlights in terms of functional headlights. But for instance, if a car goes left, and then you can project an arrow that points out that you go to the left, that also improves safety for the traffic that is on a cross point. So I think the only thing to convince a lot of the regulations and governments is that this is not just a gimmick. It really improves the safety on the road.
Yeah. Yeah, maybe the proof will come from the Chinese market somehow.
I think that will help. So if the Chinese are faster and implementing this, and people can see that it works and doesn't create chaos. I've also seen, for instance, already demos where headlight projection is being used. You can see that now if you got the Tesla. So the Tesla has a kind of display inside the car where if he's changing lanes, you can see that where you're going with the lanes. So you can do that also on the road itself. And again, that improves safety because somebody driving on the left of you can see, hey, this person is going there. So of course, the person driving the car still needs to look around and observe other participants in traffic. But we all know that if you see that somebody is going somewhere and you can anticipate yourself, that might prevent accidents to happen.
So thank you very much, Robert. So we could talk about this.
Okay, you're welcome.
Time. Thank you very much. So let's move now with our next speaker, Harald Peer from Focuslight Technologies. So Harald is an automotive lighting expert, and we'll talk about lighting for automotive. So Harald, please, the floor is yours. You can share your presentation and start.
Thank you, Jeremy. Let me try to share the screen. Okay, I move to presentation mode. Can you see everything?
Yes.
Okay.
We don't see the presentation mode. Yeah,
you
that's
don't
good.
see the presentation.
That's good. You can start.
It's good?
Yeah.
Okay. Okay, thank you for the invitation, giving us the opportunity to present our work here. Welcome to my talk, everybody. So we are just copied actually the title of the whole event. It's about photonic solutions. Disclaimer, you can read that in silence when you download the presentation that will be shared, I've learned afterwards. It's the first time now that I speak to you as a team member of Focuslight. As you all know and recently have heard now, even here in this online meeting, we have joined the Focuslight team. Focuslight has absorbed us. What happens to a particle when it absorbs another particle? It moves to a higher energy level. It becomes excited. And we're all excited. And we're looking forward to our joint future with more energy, obviously. And you can already meet us tomorrow. Several of the participants here are already in Munich. I'm not yet there, but I will be there this evening. And at further presentations, further shows in Shanghai and San Diego. Our vision, let me briefly present the company Focuslight, which may be not so familiar to you. And therefore, I would like to present you some key information. Our vision is to unlock the potential of photonics to enhance and enrich people's life. Some key facts, figures. We have, meanwhile, more than 900 employees in China, in Germany, in Switzerland, and around the world. Invest heavily in R&D, 16% annually. We have lots of patents. If you relate that to the company size, more than 430, and some key facts regarding our clean rooms and facilities. And of course, we are certified in several ISO categories and IATF also. Company is fairly young. It was only established in 2007, so some 16, now 17 years ago. It's headquartered in Xi'an, China. For those who don't know where that is where you find the Terracotta Army. These many very impressive figures that I hope to see soon. We are focused on high power laser diode components and materials. So photon generation, laser optics, photon control, and then also photonic application modules, assemblies, subsystems. On the right, you can see the main facilities where we are located and the corresponding maps down there. So summary, photon generation, photon control, and photonics application solutions. To go a little bit more into detail, what does it mean for automotive? We are featuring products for LiDAR, especially sources in particular, and also for other automotive systems like the driver monitoring system. Here you can see our lineup in laser sources, especially the VCSEL sources. And the corresponding optical elements below, so the collimators, diffusers, homogenizers, and what is coming up or will be interesting in this presentation, the optics for automotive projection and lighting. And if customers desire, we can of course also offer optical assemblies. Yeah, still core competence, automotive. I don't want to read everything what's here. You can, I'll let you take a brief look here, what we do and what our capabilities are. So we have everything that's needed to generate light, to produce not only lasers, but also full assemblies, modules, testing, of course, also testing for reliability, and also, of course, simulation tools design. Now let's move to microlens. We have heard now today already quite a bit about microlens arrays. I'm still impressed by the presentation of Oliver from Delo with these nice little movies. Why would you use microlens arrays for automotive lighting? There are multiple reasons: styling, size, flexibility, and yes, performance. The typical and first application was here the ground projection that you see on the left picture, but then headlamps came into focus, and as of 2020, now that's already 3.5 years ago, the Lucid Air was termed to have the narrowest headlight aperture of any vehicle to date. I let you challenge this if this is really the case, but this is what I've read in several publications, one of which is listed here. And now we have upcoming new applications also for ground projection, and this could be another potential target to be solved, to be addressed with microlens arrays. To support traffic safety, especially the traffic participants around the own vehicle, and also, of course, if that vehicle, if the intention of that vehicle is not very clearly seen. Now, design examples. On the road, you have already seen the Lucid Air, and there will be further models coming up, and the Genesis G90, and you see below the corresponding modules that are in use. On the left, this is a size of roughly 15 by 40 millimeters, and on the right, that is more square, that is something like also 15 by 15 millimeters. So as you can see, very slim features possible with MLAs, and also with some dynamics in the case of the Lucid. But we want to focus for today on our platform that we have started as an attempt to better understand our customers, also to move forward, to try to do also new things. For example, you see here our modular platform for next generation front lighting. And the advantage of having a platform is that enables economics of scale. The previous models were individual elements for individual cars, which carry significant cost and effort and time to be developed, spanning across multiple years. Whereas here, this platform, the mirrorless platform, is readily available. The NRE is massively reduced. You have faster time to market. And the advantage is shown, I think, pretty well in this module. You have a reduced integration space. The whole demo is just 50 millimeters thick, and it could be half as thick easily with a different thermal management, because half of the thickness is dedicated to thermal management, not dedicated towards the optical path. And you get the highest degree of customization and freedom of design here. What we do with this platform, we continue the development. It will evolve over time. We do not yet kind of commit to fixed intervals of improvement, but we are continuously working on that. So it's not a one-time shot. It's really to help our customers, to support our customers to finding their own solutions, to have a starting point which is already advanced and which will become even more advanced in the future, so that they kind of can jump from a higher level into their own design adventure with micro lens arrays. Here are a little bit more details about this platform. It is suitable for all lighting and signaling applications in the front of the car, and it could even integrate in the future multiple functions within the same light emitting surface. So this is something we also want to bring forward in the future. And on the bottom, you can see one of these modules as we have designed it. But obviously, that is not our core design expertise. And I'm pretty sure many of you in the room could do this much better. There are 3 flavors. Pure means you take what it is, this hexagonal shape. Form, you could come up or ask us request to do your preferred shape, or the full individualization, which essentially means back on track like the previous car models have been done. Here you see some of the design possibilities with mirrorless, and I think I should hurry up a little bit. As a system example, we have here 6 modules for low beam, whereas 4 modules are, that's 6 modules for low and high beam, whereas 4 modules are for low beam, including modules that make a central part of the beam, a module that extends the light distribution to the left, another one to the right, and 2 high beam modules. And some simulation results show that you can have, with a spot module alone, you have already a width of the pattern roughly from -25 to +25 degrees. Then if you look at the spread individually, left and right, you see that they are extending this pattern to almost 40 degree plus minus. And if you look at the combined picture, you can also see then the nice low beam distribution. the epic question, and with this I'm coming to the end of my presentation. What can we do for you? We can support in your design activities, fast-track development of your own MLA-based headlamp solution. We can support you in modularization, in manufacturing, and we can help you to differentiate yourself. And what can you do for us? MLA is a key component in the optical system, but other components are very important as well. We have heard already in the previous talk the role of the LED, and also Daniela's talk about the potential or the request to work on the LED sources to make them better suitable for micro and nano optics. We are interested in learning about new possibilities, new requests. What would you like to see? But also new possibilities, what's possible in prototyping, in miniaturization, in light generation. It's also a very interesting talk from Arthur. We want to hear and we want to learn about styling and solution trends so that we can support our customers better. And we are also interested in benchmarking activities and results. With this, I want to thank you for your attention, and I'm looking forward to hearing your questions. Thank you.
Thank you very much
for sharing.
Yeah, thank you for answering the question already. So any question for Harald, please? The short one. Okay, so thank you again, Harald. Thanks a lot for your presentation. And let's move with our next speaker. So Tanya Till from Techno Team. So Tanya, you are a product application developer. And yeah, the floor is yours. You can start your presentation and share your screen.
Okay, hello everyone. So can you see my presentation?
No, not yet.
Okay, perfect. Now,
yes, it works. That's good.
Okay. Okay, yes. I would like to thank also that I have the opportunity to talk today in this online meeting. And yes, I want to talk about spatially resolved light and color measurement technology. And as I heard already in this meeting, you are all very keen to develop lighting technology, everything which is luminous. And of course, this is good for us because we want to measure the light. Yeah, Techno-Team is a manufacturer for imaging light and color measurement systems. We are roughly about 65 employees. We have a lot of square meters of lab and office space. And we are located in Ilmenau. It's a nice green countryside in the middle of Germany. We are also very active in different committees like DFN, DIN, and so on. So we want to support research and development. As you can see, our customers are spread throughout the world. So we need to establish a good network in the world to support our sales and support network. So we have a lot of different companies, which are our distributors, and they do sales and technical supports in their countries for us. So why would you want to use an imaging luminance measurement device? So you can do objective quality assurance. And we are here to talk about automotive lighting. So I want to show you the interior of the car, for example. There are a lot of different areas which are luminous and of interest, of course. The display, for example, symbols, and also light guides for ambient lighting. And they all have different characteristics and also different values which are of interest, but also they have a lot of similarities for measurement. And one example is the homogeneity. Homogeneity is measured in displays, for example, white and black uniformity, and also for symbols, so that you can make sure that the whole symbol is really there and it's uniform. And for light guides, because they are so big, the homogeneity is important, so that on the right side on the car is the same luminance than on the left side of the car. So, but for the objective measurement is even more important in the exterior part in the automotive industry, because here you have to measure according to legal regulations. As you can see here on this laser pointer, on this low beam distribution here, there are these points according, for example, the ECE regulation, and yeah, they have to fulfill legal regulation values. So the challenge here in the exterior area, that it's according to law, and we do not only measure the luminance, but we have to measure the luminous intensity. So it's a different photometric value. And to realize a different photometric value, you also have to realize different kind of measurement systems. For example, here, you will have a whole laboratory with a kind of measuring wall, and in a certain distance of this measuring wall, you will place your headlamp. And of course, somewhere here in the lab is our camera installed. And as you can see here on the little labels, because of this whole setup and the knowledge about this whole setup, you are able to transform between different photometric measurement values. And here, this is the luminance intensity you want to have for headlamp measurements according to ECE, for example, ECE regulation. If you want to measure smaller modules, you can also have this whole technology in a little box, which is not as big as a whole laboratory. Since here there's an additional optic, and this additional optics realize a way shorter measurement distance of about 1 meter. By the way, this laboratory here is about 10 meters maybe, or maybe 25. This is flexible, but very big. Yeah, so here's this low beam distribution again. And what you can see here, or what's the typical characteristic of a low beam distribution, is that there's a lot of bright light and there's very less light, so very bright and very dark. So it can be that within this one image, within this one distribution, there is a high contrast. So, but what's with this high contrast? Unfortunately, very high contrast measurement is a shortcoming of an imaging luminance measurement device, because as you can see here in this video, is it still working? There will be an offset caused by scattered light. The light is not perfectly transmitted through the system, but it will be scattered at lenses or housing parts or anything what's inside. And for a lot of measurement tasks, this is, of course, yeah, disturbing. And what you can do to reduce it, you can optimize your hardware. For example, by adding anti-reflection codes or making a lot of effort to initially choose from the lenses and the materials to use for building the camera. As you can see here, anti-reflecting coating on every lens and every surface and every glass which is inside. But it's not enough to realize a high contrast measurement. So we added an additional correction called stray light correction. And so we do an additional calibration and add this to our systems. And to show this example again, so you see here this automotive LED, and these LEDs are very bright, but they have to be very dark in the background also. So a standard ELMD will show you an offset in the background, and with the high contrast optimized ILMD, you can measure your values in the background better. And it's the same case for not luminance measurement, but for the luminous intensity measurement. So if you here have a low beam distribution, you will have approximately, for example, 30 candelas in the dark zone. But with a contrast optimized system, you will be with 3 candela more into, I don't want to say correct area, but maybe you know what I mean. Yes, so that's my presentation. I hope you learned something new and listened to something interesting, and maybe you have some questions for me.
Thank you very much, Tanya, for your presentation. Any question? I was just wondering, Tanya, do you also offer services, or what is your business model? Do you offer do you sell products and offer services? How do you work?
Yeah, so our main product is the camera itself. So our customers interested in buying the camera to use on its own accord. Of course, there are other companies who own the camera from us and provide measurement for other customers, okay. But our headquarters in Ilmenau, not.
Okay, good. Any question? Okay, so thank you again, Tanya. Thank you very much for your presentation. Yes, we have a question from Michael Ham from DVM. Please, Michael, short. You are muted.
Of him. So now, sorry. Tanya, there's you show nice pictures, but give us a number. Is it the 30 candela to 10 candela? That means you improve it by 90%, the stray light?
So in this case, you can calculate the percentages exactly of this example. But of course, you cannot say with our correction, you are 100% better or something. This depends really strong on the application and depends also on the light characteristic and on your luminance scene you're looking onto with the camera or with a totally other system. So, and also we try to have like a basic correction for general applications, but we are also happy to optimize even more according to specific applications from the customer.
Okay, thank you.
Thank you, Michael. And thank you again, Tanya. Thank you again for our presentation. So now let's move on with our last but not least speaker of the day, Henrik Madsen, CEO of SPAO Systems. So Henrik, you can start and share your presentation, please.
Okay. Yeah, thank you and welcome to Denmark. I hope you can see my front page here.
Yes.
Okay, I hope to tell you some interesting, not to put you asleep. I should try to do it swift and clear. Spar System is a young company. We have been built on an idea to do something about optical engine manufacturing, to do similar what has happened for the electronic chip manufacturing. So you are shifting from individuals to wafer level. That's the principal idea about Spire Systems. So the company is come on, there it is. Is about almost a little bit more than 3 years ago. We have developed or invented a production platform or technology to make optical engines or devices, not single components, but optical devices. The whole idea is also to minimize and miniaturize the optical devices, so you can have more a new application just due to the small form factor of the devices, and not least to enable to scale your production and at the same time to lower the cost of the optical engines. We are out of a community in Denmark with Ipsen, Photonics, Karthaus technology. So we are a spin out of this ecosystem in Denmark. Today's optical manufacturing of optical instrument is quite old. It's mostly built off of discrete optical elements that you put together into a box, and that assembly can easily account for the majority of the cost for each optical instruments. And also, it's very hard to scale on short term from a few items to hundreds or even thousands and millions. And also, larger component or larger instruments is also more sensitive to external environments, make it less robust. That's all things that we would try to overcome with our technology. We want to transfer it to wafer level production, meaning that we are making components on wafer level, means that you're doing thousands of optical components in one operation. So each component is less costly. Also, we have the greatest advantage to do assembly on wafer level. So you avoid putting the things together when you have dies into individuals. And known from the chip manufacturing, it can easily increase your production capabilities. If you do that, you have less need for equipment, also less manpower. And that's really a nice time we see this geopolitics that you want to produce locally here. So we intend to be able to do it locally here, maybe not Europe or in Denmark, but also locally in Europe. And a smaller form factor also means less, more robust to external environment impact. So we are driven up from the basic idea to do everything on wafers, make optical engines out of wafers. So we don't have that much ambition to revolutionize the optical, let's say, functionality, but we can do the same product, same engines on a smaller form factor. Yeah. What are we going to do? So this is a generic process not intended for automotive lighting, but it could be part of the optical supply chain for maybe not the headlight, but also for interior lighting or sensing. We are working, as Oliver from Delo mentioned, we're working on resins that we're imprinting on wafers, glass wafers. So we put a liquid polymer on a glass wafer, and we imprint these micro optical features in this polymer. It's not as most we are seeing plate-to-plate imprinting, but roll-to-plate, mean that we have a very high capacity from this technology alone, just because it's an inline process. It's coming from the holographic industry, or on the back days also from the newspaper. So the same addressing to make volumes production. To make this replication, you need a master for that. We are sourcing partly in-house here, but also from other vendors locally here, or suppliers, also universities around Copenhagen. It's not a one kind of optics on the wafers or so the master. It's a hybrid master, so you have more functionality on the same master. When implemented these wafers with different kind of optics elements on it, you are put more wafers together, meaning that you're stacking wafers around it, bonded with bonding glue. And also you can make multiple layers of different optical elements put together. So when you combine the stack, you made an optical engine on wafer level. And finally, you need to dice it to have the optical device ready for further integration. So by this method, you can do, ideally you can do hundreds or thousands of these optical devices on each wafer stack. So we can cut out a lot of assembly costs for the individuals too. So you do a lot of you do the assembly on wafer level, meaning that even that you're using longer time for making the stack, that the time spent on each module is really a fraction of what it is today. And also by this method here, by bringing in more wafers together, we can have a very high degree of optical signal processing on a very small cubic footprint, because we have not only one layer, we have multiple layers. So we have and you can bounce the light up and down through the stack here. So we can have a really high and compact optical processing. So what do we have in our toolbox? We have all the conventional optical elements we can combine together in our optical design. You have the lenses, standard spheric lenses, but also torics and parabolic lenses. We have all the micro mirrors can put in, and also we can add gratings, ordinary triangular gratings, binary gratings, slanted gratings is a little bit hard to replicate, and freeforms mean that you can in shape. All these boxes, all the tools you can combine in a single master. Of course, it's very hard to replicate gratings with lenses, but we have seen some good progress on combining different kind of optics in one wafer. I think we have seen before how UV nanoimprint lithography is done, so we wouldn't tell that much about it. This is more interesting from end user perspective. This is an example of a double layer of wafers that combined a small module for a telecom receiver application. So we see here the green is the glass wafers, and the yellow is the resin that's becoming polymerized with all the optical elements. So this module here is 2.5 by 2 millimeter, and you have 6 lenses, 2 mirrors, some filterings, polarization filters in between. So a good example of a user case for our technology. So the summary here, we can opportunity with Spiral is we can miniaturize the optical engines or devices. We can also, that was not intended, but new application seems to be a door opener or small form factor optics to be a door opener for new applications. A good example is if you want to monitor the glucose content in blood. If you do that on wearable optics, you need a really large case to wear, but with our technology, we can have a smart watch size of measurement on the body. We can scale the volume. Also, we can have a true hybrid optical functionality, meaning that we can do more than just lenses or mirrors in one wafers. The challenge, of course, is that it's very unmature technology still. And also we need to figure out what is the manufacturing tolerance in the high volumes. Still, we use active alignment of the wafer, but one of the challenges would be that we would like to have passive alignment of the wafers in the assembly process. And then the typical question, what can you do for us? We would like to in-source meter structure or DOEs in our toolbox. We know from our lithography that we can imprint it, but we need a source of master for it. Also, the coatings, we do coat the polymer for making as a mirror, but also coats with AR to avoid backscattering. So we would like to reach out to companies that can do these kind of coatings on polymer surface without any surface degradation. And finally, we would like to take the next step to do, let's say, an integration step also to the actual components. It could be to do wafer level assembly on detector arrays, meaning it could be silicon wafers with a silicon detector arrays that match our pitch on the wafers, or opposite, we match the standard wafer. So I hope you didn't fall asleep, but that was my presentation for today. So it is a quite new approach to production. So please reach out if you're interested. We can at least have a chat for what we can offer to you.
Thank you, Henrik. Thank you very much for your presentation. And yes, Daniela, you have a question?
Yes, thank you for the nice presentation, Henrik. So I think we already stood in contact. So my question would be, do you have a standard software that you use for, or that you can, sorry, I lost the word, that I could, for example, also use for a design or for simulating these types of optics?
Yeah, glad for the question. It is actually a little bit a dark hole because it's a new approach to do a design. You have a sheet of paper, then you do the design on a sheet, but now we have a multi-layer of optical components on top. So there's no standard, let's say, software that can be used one-to-one. And also the design is very dependent on the process to manufacture it. So that's why we're offering to help transferring today's application to our technology, because we know that we cannot take a standard design and just make it on our process. So we need to make it a redesign or make it from scratch. But we use CMAX, and we have some tricks to use CMAX.
Okay, thanks a lot.
Thank you, Daniela, for our question. Robert, yes, from Pioneer US.
Hi, thanks for the talk. Two questions. The one is, what is the maximum ZAG height of lenses you can imprint with your process to have with good shape accuracy, or which height is possible with this process? And the second is about the stacking. How do you align? Is it a special tool again? And how do you generate the spaces for that stacking?
Okay, two questions about the maximum ZAG height. We have imprinted up to 180 micron, both for spherical and aspherical and elliptical lenses. Of course, that thick layer of resin on a relatively thin layer of glass can do some stress in the glass. That's one of the motivation to transfer to a meter structure, because you can do the same kind of optical manipulation or signal processing on DOEs or meter structures. But we do quite good form accuracy, less than 10 nanometer on these kind of lenses. And about the stacking, that's some of our internal work we are doing. We are building our own stacking machine. There are some commercial level machines that can do that, but we think that we lack of flexibility, because we can work on very thin wafers and very thick wafers. So that's one of our core expertise, and we want to have, let's say, control that very accurately. So we do our own stacking machine, but also with commercial bonding equipment. And I would love to tell, but I wouldn't tell you here in public how we're doing it. But we have very good 6-axis control of wafers.
Thanks. And which size of wafers you're using currently with this machine?
We're working on a 6-inch platform.
Okay. Thanks.
Thank you, Robert. Any other question or last one before to end this meeting? Okay, so thank you again, Henrik, for your presentation, and I would like to thank all the speakers today for your highly relevant input and all the participants for the question. So thank you very much. We hope that you enjoy this online meeting and see you for the next time. Thank you very much. Bye-bye.